In this video, we will be discussing creating solid primitives, the basics. If you'd like to follow along with this video, please open the file create solid primitives-thebasics.dwg located in the working files folder as discussed in the working with this dataset video. 3D solid modeling is used across multiple design disciplines. Using solid model primitives is a key to creating your designs. You can use solid model primitives individually or in conjunction with other solid models to create complex designs. 3D solid models help improve visualization, which improves communication and development of the design. Additionally, 3D solid modeling helps to reduce errors and decrease the time required to complete a project. So let's first start with the box command. Let's go ahead and set our layer to a-box, and all the primitive solid tools are located in the Home tab, Modeling panel, and then we have the Solid Primitives dropdown. As you can see, we have a total of 7 solid models that we can start with. And then, of course, later on in the course, we'll talk about how to actually combine these into the complex design models that will take on your actual design. So first, select the box command. Again, when you don't know what to do, look to the command line window. At this point, we are specifying a corner point for the box to begin. So we'll go ahead and just simply click anywhere in the design file. Notice, as long as you have dynamic input turned on, you have the ability to type in the actual values. There's also an option for cube and length options right here in the command line window if you want to define your box that way. For now, though, let's go ahead and simply type in 100, 50, and then press enter. As soon as you do so, you're now entering into the option to define a height for the actual box. Notice the option to define a 2-point distance. This is a great way to grab a height of a 2D view from within your drawing. We'll go ahead and just type in 100, and there's our box completed. Let's press enter to repeat the last command to look at another way that you can actually type this in. So let me go ahead and click first in the drawing. Now, if you want to complete the command in one full sweep without having to type in the length, width, enter, and then the height, you can actually do this all at once. So all you have to do is type in 100, 50, 100, and press enter, and there's the same box just in one step. Pretty cool. Let's press enter again to repeat the last command, and let's look at the center option available in the command line. Go ahead and select center, and now what you're doing is you're defining the center of the actual box. So this is the center of the entire box, and that's not just the center of the length and the width, that's the center that includes the height as well. So we'll go ahead and click in here, and now, depending on which way you move your cursor, you can define the half distance that you want. So we'll type in 50, 25, and press enter. And now, as you can see, we're defining the actual height from the middle of the cube. So we'll go ahead and just type in 50, press enter, and now we have that total distance defined. Let's go ahead and look at the cylinder command. Let's change our layer to a-cylinder and change the tool to the cylinder dropdown here. Again, when you don't know what to do, look to the command line window. You have a few ways to define your cylinder. By default, you're defining the center point. Let's just go ahead and click in space. And now you're simply defining the radius, or in the command line, you can choose the diameter option. We'll just type in 100, press enter, and now for a height, notice how you have a few options. You can define that 2-point option, which is very nice, or the axis endpoint option. Let's go ahead and actually select the 2-point option to see what it actually will do. AutoCAD is prompting you to define the actual distance from an object or objects in the drawing. Let's say we want it to be the same height as this box here. What you have to do is simply snap to the endpoint there, snap to the endpoint there, and it automatically grabs that distance. That's a great way to grab distances from existing objects that could be defined actually in a 2D view. Really cool. Let's go ahead and press the cylinder command again, and let's look at the elliptical option. So with the elliptical option, you're basically defining a 2D ellipse. So you're first defining the endpoint axis, then the other endpoint axis to the first axis, and of course, now you're defining the second axis endpoint as well. And then, of course, you simply define a height here. Again, don't forget, you can always snap to existing objects to get their value as well. Let's change our layer to a-cone and look at the cone command. We'll click the drop down and click cone. And again, look at the command line window when you don't know what to do. You're defining the center point of the actual cone. So go ahead and just click in space somewhere. And now you're simply defining the base radius, or as you can see in the command line, you can choose the diameter option. We'll go ahead and just type in 50, press enter. Now, what's also really cool is you can actually define a point or height for this cone, which is fine. So we'll just type in 50, press enter. If we press enter again to repeat the last command, let's go ahead and just define our center point again and type in 50, press enter. What you can do now is you can actually define a different top radius, which is really nice. So if you want to do some sort of object that does not actually go to a point or a pyramid, you can do so as well. Let's say the radius here is half, so we'll type in 25 and press enter. And now you're defining the height for this cone object. So you could type it in or snap to an existing object. Pretty neat. Let's change our layer to a-sphere. And the sphere command is fairly straightforward. You can define a 3-point, 2-point, or tangent radius. In this case, we'll simply define the center point here, and then all you're doing is defining a radius for this sphere. Pretty simple and straightforward. Notice how it does it at the center, and that's where it actually defines it. If you needed to define the sphere to a location on top of something, you would have to move it afterwards. Let's look at the pyramid command. Let's set our layer to a-pyramid and start the pyramid command. So the pyramid command is not limited to the 4 sides of a pyramid. You can actually define as many sides as you want. If we look at the command line window, by default, you're defining a center point of base. But notice the options available. You can do it by number of edges or by the actual side length. So we'll go ahead and just simply define a center point here. And as you can see, it's just the center to the edge of the actual pyramid here. Notice the option for inscribed. By default, it's doing circumscribed. So we'll just type a distance here of 50, press enter, and then a height that you want. We'll just type 50 again and press enter. And there's a pretty simple pyramid. Again, you're not limited to just a default pyramid. You can define it by the sides here. If I type in S for sides, I can now define this as, let's say, a 9-sided pyramid. Now you're back to specifying it by the center point. Again, if you want to define it by the edge, go ahead and click on edge, and then you're actually defining it by the edge length here. So I can lock my polar tracking and type a distance of 50, press enter, and now you're defining the actual height. If you want the radius to be different, go ahead and choose the top radius option. And let's just make this 10, press enter. I now have a 10 unit top radius. If I want to grab a distance from the drawing, I could use 2-point for the height, or of course I could snap, and now I have the same exact height as this object here. Let's look at the wedge option. Let's set our layer to a-wedge, and go ahead and choose the wedge command. Notice the option to define it by the center point. What you're doing with the wedge is you're simply defining it by the first corner. So if I click in space, you're now defining the other corner. You can also define a length here. Again, using dynamic input, you could simply type in 200, 100, and press enter. You are now defining the height for the wedge. Again, notice the 2-point option, or you can just type in a value and press enter. If we start the command again and choose the center option, it's the same exact thing as the box. You're basically defining it from the center. So I could type in 50, 100, press enter, and now you're defining the wedge part from the center of the actual wedge, and there is my distance for that wedge. Lastly, let's go ahead and set our layer to a-torus and start the command. Pretty simple here, 3-point, 2-point, or tangent radius, and what you're doing is you're first defining the radius for the actual torus. Let's go ahead and type in 50, press enter, and then you're simply defining the actual value for the tube radius. Notice the option to choose a distance from somewhere in the drawing. So we'll just go ahead and type a distance in of 10, press enter, and there's our torus. Very simple. Do a zoom extents to fit your drawing, and this is how you define solid primitives.